Hey everybody, this is Miss Berry back for the second part of our section 1.3 video. So I'm going to go ahead and share my screen and we will finish up this section. All right, so finishing up section 1.3, polynomials and factoring. The part one of this video is really just kind of like a refresher and an introduction to polynomials and their terminology. And then just a little brief intro to factoring. We're really going to get into the important material in this video. All right, so factoring special or using special factorizations. That's what I like to call them, special factorizations. All right, so we have three special factorizations. This is stuff that I would put on your formula sheet. So all three of these, in my opinion, should go on your formula sheet. Now, if you don't like the format with the variables, like if you don't like the A and the B, if you'd rather have X and Y, totally fine. Just change them to X and Y. You could have like X squared minus Y squared is X minus Y times X plus Y. Or if you would rather see it with numbers, that's fine too. You know, on your formula sheet, I want you to put whatever helps you the most. All right, so three different special factorizations. Make sure you're writing these down if you don't have the notes printed out. The first one is a difference of squares. Then we have a difference of cubes, and then a sum of cubes. All right, so squares and cubes, that refers to what exponent is being used. So a square, you're going to have the exponent of 2. A cube, you're going to have the exponent of 3. All right, so difference of squares. This is where you have a perfect square minus a perfect square. They will typically look like this problem at the bottom, like x squared. I was trying to draw an arrow, but it really went off the rails there. Like x squared minus 49. What do I mean by a perfect square? Perfect squares are going to be those numbers that have a perfect square root. All right, so for example, 1 squared is 1. So that's a perfect square. 1 is perfect square. 2 squared is 4. That's a perfect square. 3 squared is 9. So 9 is a perfect square. 4 squared is 16. If these aren't familiar, if you feel like, oh my gosh, she's like coming up with these so fast, this might be something that you want to add to your formula sheet as well. If you already know all these by heart, then of course you would not want to waste the space on your formula sheet with those. So, I think I stopped at 5. 5 squared is 25. 6 squared is 36. 8 squared is 64. I think I missed this one. 7 squared is 49. 9 squared is 81. 10 squared is 100. I would go to 12. 11 squared is 121. 12 squared is 144. And don't be like me, write neater so you can tell that that 2 is in the exponent. Yeah, so keep it as neat as possible. All right, so those are our first few perfect squares. If you know further than that, then that's great. That might be even more helpful if you have all of those memorized. Right, so difference of squares, the formula is a squared minus b squared is a minus b times a plus b. Right, so difference of cubes is where we have two perfect cubes. So a cubed minus b cubed, that turns into a minus b times a squared plus ab plus b squared. And then for a sum of cubes, you have a cubed plus b cubed, so sum of cubes. A cubed it's a cube, and then you're adding, so it's a sum of cubes. And that formula, if you notice, it's very similar to the one we just read. A cubed plus b cubed is a plus b times a squared minus ab plus b squared. Let's talk about how they're different. The difference of cubes, the formula starts off with a minus. Sum of cubes, the formula starts off with a plus. I remember this by like whatever is in the problem, that should be in the first set of parentheses. So the sign should match there. Minus matches with minus. Plus matches with plus. All right, and then for the difference of cubes, we have starting with a minus, then the next sign is a plus. Sum of cubes start with a plus, next sign is a minus. On both of them, the b squareds are positive. All right, so hopefully that helps you differentiate those. Just be careful when you write them down. Make sure you put them down in the correct order. And when you're reading them off on the test, make sure that you are reading special factorizations to factor the binomial x squared minus 49. All right, so sometimes for some people, this will be super easy. For some people, they have a little bit harder time with this. So you may be able to jump straight to the answer, and that's fantastic. Use a different color, sorry. Oops. If you can jump straight to the answer, like I said, that's great. If you can't, that's okay too. I don't know why my pen's not showing up in the right color. All right, so you're going to match this up and say, okay, in my formula, the A is getting replaced by X. So this A, both of these little A's are going to become X's. Now, it's supposed to be in that perfect square format, so you need to change 49 to be 7 squared. All right, so now you can match it up. The 7 matches with the B, the squared matches with the squared. All right, so B is going to get replaced by 7. 7, 7. All right, now you just need to fill it in. X minus 7 times X plus 7. That's it. So not terribly difficult. Okay. Let me add in a blank page so I can talk about perfect cubes. All right, so first few perfect cubes. You may not have these memorized. That's okay. You can add them to your formula sheet. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 25. 6 cubed, 216. I'm pretty sure that's as high as I ever have them go. But let's do 7. 7 cubed is 343. How many of y'all knew that already? If you do, you're better than I am. 8 cubed, 512. I really don't remember them ever getting this high on hogs or on my test or on my practice exams. Right, but these are our first few perfect cubes. Of course, you could go on and on. The only one that ever seems to cause people problems is this one right here, because 64 is also a perfect square, so sometimes it throws people for a loop and they end up using it in the wrong spot. All right, so just remember, 8 squared is 64, but 4 cubed is also 64. All right, so 64 is a perfect square and a perfect cube. And of course, 1 is as well. 1 is a perfect square and a perfect cube. All right, let's look at, I'm going to skip this one because it's very similar to the one we just did. Very similar to part A. Let's look at C, y cubed plus 64. Right, that's a sum because you're adding, so it's a sum of cubes. You see the cube there, that's the tip off. Right, so let's write our formula. A cubed plus B cubed, that is A plus B times A squared minus AB plus B squared. Okay. All right, so let's plug in our numbers. All right, so we need to figure out which perfect cube is 64. We just talked about that. We know that it's 4 cubed. And now we're going to figure out what do we need to match up. A, in our problem, A is going to get replaced by Y. So A, do a different color. A gets replaced by Y. B, that's the number that's being cubed. So B matches with 4 with the cube. So B gets replaced by 4. All right, so let's plug everything in. A plus B, that's going to be Y plus 4. A squared, that's Y squared. Minus AB, so that's 4 times Y, Y times 4. What's Y times 4? We always put the variable at the back, so just switch that. That's 4y plus b squared. B is 4, so 4 squared. Go ahead and simplify that. 4 times 4 is 16. You got it. Oh, one important thing to note that I forgot about till this moment is very conveniently, this polynomial here, the trinomial that's in the second set of parentheses, when you use a sum of cubes or a difference of cubes formula, special factorization, that second polynomial is never factorable. All right, so that one is never factorable. You never need to take it any further than that first formula, right? So you never have to break that down any further. That polynomial will never be factorable, right? And again, that applies to this polynomial and this polynomial for a difference of cubes and for a sum of cubes. Whatever you come up with for that second polynomial, the second set of parentheses is never going to be factorable. Very convenient. All right, this one a little bit harder. This is a difference of squares. I can tell because this is minus and it's got a square, so it's a difference of squares. All right, so this one's a little bit harder because we've got a number in front of the variable, but you will notice that it's a perfect square. So 4 is 2 squared. 121, that's 11 squared. Now you just have to do a little bit of work before you can use the formula here. So what you have to do, and this uses your exponent rules that you learned in the last chapter, is you pull that exponent out. That becomes 2x all squared. So again, if you were to multiply this back out or to expand it, you would distribute the exponent to both terms. It would become 2 squared plus, or excuse me, 2 squared times x squared, which is the same as what we just had. All right, so once you've got that simplified, then you're going to apply your difference of squares formula, which looks like this. B times A plus B. Also, something that people sometimes ask is, can you switch the order of these? That's totally fine. If you write this A plus B times A minus B, it's the same thing. It's just that commutative property of multiplication that, like, for example, 4 times 3 is the same as 3 times 4. Right? So when you're multiplying, the order does not matter. That's what we're. All right. So now we're just identifying what do we need to plug in for our particular problem. A is going to get replaced by 2x. So A becomes 2x. And what do you think B is going to get replaced by? Should it be negative 11? Should it be negative 11 squared? Then the negative is not part of it. All right, so the minus matches with the minus. The B matches with the 11. The squared matches with the squared. All right, so B is just 11. All right, so now we'll plug that in. Switch back to blue. That was our formula. All right, so that's just a little scratch work. Then our answer is going to be 2x minus 11, 2x plus 11. All right, so looks a little bit complicated. You have a little bit of the extra work at the beginning that you have to do, where you have to pull out, first you have to replace that coefficient with its perfect square form, and then you just pull out that exponent. But it's the same concept. All right, let's get into factoring. All right, so the last half of this video would deal with factoring. All right, so we're going to start with the factoring trinomials, the most simple case. This is where your leading coefficient is 1. All right, so the steps here are, you're going to look at your polynomial. You see the leading coefficient here is 1. All right, it's in descending order. It's an x squared at the beginning. There's no number out front. We can assume that there's a 1 there. All right, so what you can do here is you want to look at this last term. All right, so look at this last term. And you want to come up with the factor pairs. So things that multiply to give you 21. All right, so what are some things that multiply to give you 21? 1 and 21, and 3 and 7. Anything else? You could do -1 and -21, or -3 and -7. Right. All right, so now we are going to make this little table. Now, you might be able to do this in your head, in which case that's totally fine. But if you can't do it in your head, that's fine too. I'm going to show you how to do it by hand. All right, so I always make this little table, and in the left-hand column, I call this pairs of factors. And in the right-hand column, I call it sums of factors. Sum meaning add. Sums of factors. And then usually in the future, I just abbreviate this POF and SOF, so I don't have to write that every time. So I'm just going to start by writing my factor pairs, 1 and 21, 3 and 7, -1, -21, 7. Right, so those are all the things that multiply to give you a positive 21, which was our constant term. All right, then you're just going to add those factors together to fill in the sums of factors table, or column, I should say. 1 plus 21 is 22. 3 plus 7 is 10. What's -1 plus -21? Be -22, right? -3 minus 7 be -10. All right, so then what you're going to do is you ignore everything else for just a second, and you're just going to focus on this side. All right, so you're looking for the sums of factors, or the sum of factors that adds up to match the middle term, the coefficient on the middle term. All right, so you're looking for a -4. Do y'all see a -4 in this sums of factors column? No, none of those are -4. If none of your factor pairs add up to the middle term, that means it is not factorable. Not factorable. Right, so this was a terrible first example. That was an accident. I think I just wrote a sign wrong when I made this up. But this one is not factorable, and that'll happen every once in a while. You'll get one on the homework that's not factorable. Let's do one that is factorable. Right, so here we go. We're going to do the same thing. We're going to make that little table. We're going to make the little table. Pairs of factors, sums of factors. All right, so in the left-hand column, you're just writing things that multiply to give you the constant term. All right, so -15. So you could do -1 and 15, +1 and -15. You could do -5 and 3, or +5 and -3. There's nothing else that multiplies to give you 15, so we can move on to the sums of factors column. All right, so you're just adding these together. What's -1 plus 15? 1 minus 15 would be -14. -5 plus 3 is -2. 5 minus 3 is +2. All right, so we're looking for the coefficient on our middle term, which is +2, and there we go. We found a match. All right, so when you find a match, that means it is factorable, and you're going to go on and write your answer. And the way that I like to describe this is you're going to make two little binomials. The first piece is always going to be whatever your variable is. So in this case, it's x. All right, and that's kind of like your template, is you set up your two little parentheses, you put your variable in the front, and then you're going to fill in your factor pairs. So right here, a +5 and a -3. +5, -3. And you're done. You can check your answer on these. You just FOIL this back out, and you would get back to that x² + 2x - 15. that's your final answer. All right, so whenever you have a leading coefficient of 1, we have this pretty straightforward method for factoring. Let me see if I have any more. No, we're jumping into the more complicated ones now. So let me back up and talk about the case where the leading coefficient is not 1. And if I'm going too fast, of course, you can pause the video, back up, rewatch it again, figure out, take a little bit more time and work it out on your paper. All right, so I like to call this the AC method. Now, you can use the AC method for every polynomial. It's just not always the fastest way. So you can use the AC method, I should say, for every trinomial. But it's not always the fastest way. If your leading coefficient is 1, it's much faster to do this method where you just look at the last term, look at the constant term, find the factor pairs, and then add them up to figure out which one matches the middle term. The AC method is the best method, in my opinion. There's other ways to do it, but this is the best method for the situation where your leading coefficient is not 1. All right, so this is where we're working with a polynomial that looks like this: ax squared plus bx plus c. A, b, and c are being replaced by numbers. So maybe it's like 6x squared plus 10x minus 12. All right, so a, b, and c get replaced by numbers in this scenario. All right, step 1 is to multiply a times c. All right, and really I should add in before this, you should always look for a common factor. Whoops, sorry. Always look for a common factor first. If you can factor out a common factor, it makes it so much easier. All right, so if you don't have a common factor, like for example, if you have something like 6x squared plus 12x minus 20, you could pull out a 2. 2 goes into 6, 2 goes into 12, 2 goes into 20. All right, but if you had something like minus, I don't know, let's do something that I know won't work. 4. No, that won't work. I will do 5. All right, so if you had a 5 there is no common factor. There's nothing that goes into 6, 12, and 5 besides 1. So there is no common factor to factor out. So sometimes you'll get lucky and you get one with a common factor, and sometimes they don't have a common factor. Oh, let me get that erased. All right, there we go. Okay. So once you've checked to see if you can factor out a common factor, do that if you can. If you can't, that's okay. Go ahead and move on to step 1, which is to multiply a times c. All right, so that means you're going to multiply the leading coefficient by the constant term. All right, so leading coefficient times constant term. And you're just going to do this off to the side. This is like your scratch work. All right, so you go over here to the side and you'll write out whatever a times c is. All right, then you do a whole bunch of extra scratch work over here. You're going to factor AC into 2 integers. You're going to say, okay, what are some things that multiply to give me AC? And you're trying to find the factor pairs that add up to the middle term, just like what we were doing before. If no factors exist, the trinomial is not factorable. If so, we go on and we're going to factor by grouping, but I'll show you that. Let's do an example. It's much easier to see if we have an example. All right, so again, factor. If it can't be factored, write not factorable. 6x squared, plus 5x minus 6. All right, so you're going to check first and see if there's a common factor. Is there anything that goes into 6, 5, and negative 6? No, nothing goes into 6, 5, and negative 6 besides 1. All right, so we're going to move on to step 1, which is to multiply a times c. All right, so a is the leading coefficient, c is the constant term. And again, all this is happening over to the side. This is just your scratch work. 6 times negative 6 is negative 36. All right, then let's make our little table just like before. Let's make this bigger. Oh, goodness. All right, so pairs of factors, sums of factors. All right, so we're looking for things that multiply to give us negative 36. Right, so what are y'all's ideas? What do y'all think? Things that multiply to negative 36. Of course, negative 1 and 36. Positive 1 and negative 36. Could do negative 6 and 6. Yeah. You could also do 9 and 4. So let's do negative 9, positive 4. And then positive 9, negative 4. Oh, also 12 and 3. Negative 12, positive 3. Positive 12, negative 3. All right, so we're going to start working on our sums of factors. I'm going to do that in a different color. And we are looking for the coefficient on the middle term, 5. All right, so we're adding these up. In the back of our minds, we're thinking, okay, I'm looking for a 5. Right off the bat, I can tell that these aren't going to work, right? Negative 1 plus 36 is 35. 1 minus 36, that's negative 35. Not bad. Negative 6 plus 6 is 0. Negative 9 plus 4 is negative 5. Close. 9 minus 4 is positive 5. There we go. Once you find what you're looking for, don't worry about doing these. You don't have to fill that table in. This table is for nobody but yourself. So once you find the factor pair, the correct factor pair, stop right there. All right, so previously, when we were factoring those simple trinomials, we were able to jump straight to the answer at this point. But unfortunately, with these more complicated trinomials where you have a leading coefficient other than 1, you cannot jump straight to the answer. All right, so we're going to take the middle term, 5x. Let me see. I'm going to actually erase this little box around it. I'm going to try to erase the box around it. Goodness. I don't know. Yeah, I'm struggling. Okay, we're not going to worry about it. Perfect. Okay, figured it out. All right, so once you have found the correct factor pairs, the factor pairs that add up to the middle term, then you're going to take that middle term and you're going to split it up. All right, so it gets split up into 2 pieces. All right, so the 2 pieces that it gets split up into, that's determined by what you just found. All right, so 9 minus 4. 9 minus 4 is the same as 5. So this is going to become 9x minus 4x. Would y'all agree that that is the same thing as 5x? What do y'all think? Is 9 minus 4, 9x minus 4x the same thing as 5x? Yeah. 5x is the same thing as 9x minus 4x. All right, so we have not changed anything. Just making a note of that. We have not changed anything. All right, so everything else is just going to get dropped down. I don't know why my cursor has all of a sudden disappeared. All right, 6x squared, that 9 is positive, so let's throw a little plus in front of it. And then the minus 6 gets dropped down. All right, so here's what we're working with. Here's what we're working with. All right, so let's take a second and look at that and think if that's something we've seen before. 6x squared plus 9x minus 4x plus 6, or excuse me, minus 6. All right, so this has 4 terms. Would you all agree with that? It has 4 terms. All right, now we said earlier in the last video, if a polynomial has 4 terms, we know how to approach it because those problems, they're very easy to identify. If you ever see a polynomial with 4 terms, you know that you're going to be doing factoring by grouping. All right, so you're going to factor by grouping. All right, so you're going to group the first 2, group the second 2, And we're going to do just like we did before. We are going to look at the first group right here. We're going to say 6x squared plus 9x. What number factor do those have in common? What goes into 6 and goes into 9? 3, right? Right, and then we have x squared and x. So how many x's do they have in common? Just one x, right? Right, so that's our greatest common factor. Right, so we're going to pull out a 3x, and we're going to write what's left over right here. Right, so 6 divided by 3 is 2. 2 x's take away 1 x. That leaves us with an x. 9 divided by 3 is positive 3. X, take away x. X's are gone. Right, now we're going to look at the second group. Minus 4x minus 6. What do those have in common? 4 and 6. What goes into both of those? 2 goes into 4 and 2 goes into 6. And since they're both negative, you do want to go ahead and pull that negative out with it. Right, so negative 2 goes into both of those. Right, you're going to write what's left over once you divide. Negative 4 divided by negative 2, that gives you a positive 2, because a negative divided by a negative is a positive. We have an x. We didn't take away any variables, so that x just drops down. Negative 6 divided by negative 2, that is a, sorry. That is a plus 3. And just like we had said before, sorry, I don't know what happened there. Okay, there we go. Just like we had said before, whenever you are doing factoring by grouping, you should always look out for having the same thing inside the parentheses. Sorry, I'm really struggling with my cursor right now. All right, so we're going to have the same thing inside the parentheses, 2x plus 3, 2x plus 3. That tells us, oh, great, we're on the right track. This is going to be factorable. We're going to go ahead and put that common factor out front. The common factor out front is 2x plus 3. Right, you're going to write the leftover stuff at the end. Right, the leftover stuff, that's going to be 3x and then minus 2. That's just the stuff that's in front of those parentheses. All right, so 3x and then minus 2. Right, and there you go. Now, one thing I did forget to mention as I was struggling with my pen here is, one thing I forgot to mention is that at this step right here, when we wrote those factor pairs, some of you may have written this in the opposite order. You might have, when you were over here writing your pairs of factors, you might have wrote -4, 9. It's totally fine. There's nothing wrong with that. But that would have made you perhaps write down -4x plus 9x. Again, totally fine. The only difference is that you would probably at the end up with these switched. So they would be like 3x minus 2 in the first parentheses and 2x plus 3 in the second parentheses. But we know that that's totally fine because of, again, that commutative property of multiplication that says that the order doesn't matter with multiplication. So 2 times 3 is the same as 3 times 2. All right, so if you switch the order here and you had -4x plus 9x, that would be totally fine. There's no incorrect way to write those factor pairs whenever you go back in and split up the middle term. All right, so just so you know. All right, I'm going to stop the video there. There's one more example, but since my pen is not cooperating, I'm going to go ahead and stop the video there. And if you want to see more examples, let me know. I can make some more videos where I'm just going through examples of these. But if you do have any questions, please let me know. Send me an email, post in that discussion board, and I will be happy to help you however I can. Thanks, and I'll see you in the next video.